Moons, cosmic guardians, or hidden destroyers? What if the moon wasn't just a serene companion lighting our night sky? What if it held the power to unleash chaos, destabilize planets, or even destroy civilizations? This isn't the premise of a science fiction novel, it's a reality lurking in the cosmos. Welcome to Galactic Discovery's Quest, where today we're exploring the duality of moons. These celestial bodies, often seen as life-sustaining stabilizers, also harbor the potential for unimaginable destruction. Could our moon ever turn against Earth? Are there rogue moons in distant star systems already destroying planets? And how do these enigmatic satellites shape the universe? Join us as we unravel the mysteries of moons, their role as protectors, creators, and potential harbingers of doom. By the end of this journey, you will never look at the night sky the same way again. The unseen power of moons. Moons are far more than celestial ornaments. They are silent architects that shape their planetary systems in ways we're only beginning to understand. But to grasp their potential for destruction, we must first appreciate their vital roles. Moons across the solar system. Our solar system alone boasts over 200 moons, ranging from tiny, irregular rocks to massive, planet-like bodies. Each moon tells a unique story. Earth's moon, our stabilizer, creating tides and ensuring a habitable climate. Jupiter's Io, a volcanic hellscape, constantly reshaped by eruptions. Saturn's Titan, a world with rivers and lakes of liquid methane, potentially hosting exotic life. Neptune's Triton, a captured rogue moon with icy geysers. Moons don't just accompany planets, they shape their fates. Without them, many worlds, including Earth, might not support life. Earth's moon, a silent guardian. Earth's moon has been a faithful companion for 4.5 billion years. It stabilizes our planet's axial tilt, ensuring consistent seasons. Its gravitational pull creates ocean tides, which have shaped ecosystems and driven evolution. But here's the startling fact: the moon is drifting away from Earth at a rate of 3.8 centimeters per year. Over billions of years, this gradual retreat could destabilize Earth's rotation, leading to erratic climate swings. While this won't happen in our lifetimes, it highlights the delicate balance between a planet and its moon. What happens when this balance is disrupted? Let's explore the darker side of moons. When moons rebel, moons are typically seen as stabilizers, but their orbits can change. And when they do, the results can be catastrophic. The escaping moon. Imagine a moon slowly drifting away from its planet, like our moon is from Earth. As it moves farther, its influence weakens, destabilizing the planet's rotation. But what if the opposite happens, a moon spiraling inward toward its planet? This scenario is rare, but it's not impossible. In such cases, the moon's gravitational pull intensifies as it approaches the planet, setting the stage for a catastrophic collision. The tug-of-war. The interaction between a planet and its moon is a delicate tug-of-war, dictated by gravitational forces. When these forces become unbalanced, due to external perturbations or internal dynamics, the moon can either drift away or spiral inward. If a moon spirals inward, the result is an apocalyptic collision. The energy released in such an event would vaporize the moon and obliterate much of the planet's surface, leaving behind a desolate, unrecognizable world. Cosmic catastrophes. Collisions between moons and planets aren't just theoretical. Astronomers believe they've already occurred in distant star systems. Let's delve into the mechanics of these apocalyptic events. The dance of death. Astronomers at the University of California have modeled scenarios where moons spiral inward, leading to violent impacts. Here's how it happens. Orbital decay. A moon's orbit becomes unstable due to gravitational interactions with its planet or neighboring moons. The spiral effect. As the moon moves closer to the planet, its speed and gravitational pull intensify. Impact: the final collision releases enough energy to melt the moon and devastate the planet. The aftermath includes global destruction. Vast portions of the planet's surface are vaporized. Dust clouds: debris blocks sunlight, plunging the planet into a global winter. Mass extinction: any existing life forms are wiped out in an instant. Astronomical evidence: astronomers have observed dust clouds around distant stars, possible remnants of moon-planet collisions. These clouds serve as eerie reminders of the destructive potential lurking in planetary systems. WASP-12b, a planetary tragedy. One of the most chilling real-world examples comes from WASP-12b, a gas giant located 870 light-years from Earth. The gravitational nightmare WASP-12b orbits its star so closely that it completes a revolution in just one Earth day. This proximity subjects the planet to intense gravitational forces, which are slowly tearing it apart. If WASP-12b has moons, they too are likely doomed, either spiraling into the planet or being consumed by the star. This haunting scenario underscores the fragility of celestial systems and the destructive power of gravitational forces. The elusive hunt for exomoons. While moons in our solar system are well studied, finding moons beyond it, exomoons, remains a challenge. Yet these distant moons could hold the key to understanding the cosmos. Why are exomoons hard to detect? Exomoons are elusive because they are small and faint compared to their parent planets, often hidden in the glare of their stars. The transit method: one way to detect exomoons is by observing tiny dips in a star's brightness as a planet, and potentially its moons, pass in front of it. However, the signals are subtle, requiring advanced technology and precise measurements. Despite these challenges, researchers have identified promising candidates, fueling excitement about what exomoons might reveal. Moons as cradles of life. Not all moons are destroyers. In fact, some may be the best places to find alien life. Europa and Enceladus, oceans of possibility. Two moons in our solar system, Europa and Enceladus, are prime candidates for hosting life. Beneath their icy crusts lie subsurface oceans, potentially warmed by hydrothermal vents. These environments could harbor microbial life or even more complex organisms. Exomoons and the search for life. Exomoons orbiting planets in the habitable zones of their stars could also support life. Imagine a moon with Earth-like conditions, orbiting a massive gas giant. Its night sky would feature a stunning view of its parent planet, creating a landscape straight out of science fiction. The dual nature of moons. So why do moons walk this fine line between creation and destruction? The answer lies in their gravitational dynamics. The anthropic principle: the fact that we exist in a universe where moons stabilize planets instead of destroying them, may not be a coincidence. According to the anthropic principle, the universe appears fine-tuned for life because we are here to observe it. But what if the balance were slightly different? How many civilizations might have been wiped out by rogue moons before they had a chance to flourish? Humanity's relationship with the moon has been a source of inspiration and wonder for millennia. From ancient myths to the Apollo missions, it has shaped human culture in profound ways. But as we look to the future, we must also consider its potential dangers. Could our moon ever become a threat? And how should humanity prepare for the challenges posed by moons in distant star systems? The future of moon exploration as we venture deeper into the cosmos. Understanding moons will be critical. New technologies, such as next-generation telescopes, could help us identify potentially dangerous moons and learn more about their behavior. The search for alien moons. Future missions may allow us to directly observe exomoons for the first time. These discoveries could revolutionize our understanding of planetary systems and the role of moons in shaping the universe. Guardians or destroyers? Moons are among the most fascinating objects in the cosmos. They stabilize planets, create tides, and may even host alien life. But they also have the potential to wreak havoc, turning from guardians into destroyers in an instant. What do you think? Are moons more friend or foe? Could they one day spell the end for civilizations like ours? Share your thoughts in the comments below. And if you enjoyed this exploration, don't forget to like, share, and subscribe to Galactic Discovery's quest for more cosmic mysteries.